Section 8. Modeling with Design Aids. This is an additional section to this module, which can also be discussed together with the assignments of a course reinforced concrete design. We mentioned this in the previous videos, that from the education's point of view, it is most likely that your lecturer will ask you to do the manual calculations for a reinforced concrete structures, which you can do it through manual calculations or use the spreadsheet to help you with the design. The purpose is to ensure you go through every single calculation steps to see the connections based on what you have learned from the lecture to be applied into the project as a part of the exposures to the industrial practices. Some lecturer may require you to have an exposure in terms of the usage of the modeling software that are commonly being used in the local industry. Some may offer this as another course, specially designated for the usage of the software. Whichever it is still very closely related to the reinforced concrete structures. On that purpose, maybe we have a short discussions on this. In fact, there are quite a number of software in the market which is related to the reinforced concrete design. These include the Esteem, Tekla, Orion, Step Pro, and etc. I believe nowadays the construction industry now is more established. We have more and more options in terms of the software that you can use to model the structure in 3D, model the situations in terms of the loads acting onto the structures, the structural frame system, and etc. Based on the analysis, you are able to determine the loads acting onto each member, and the software will help you to design every single member, and some even provide you with the necessary detailings which you can adopt them in your technical drawing. This can significantly increase the productivity of an engineer producing more structures, and they have several projects that can run concurrently. Of course, there is one more thing that you need to know about using the software, that you require strong fundamentals in terms of the technical knowledge as well as the knowledge on the practical side. The software will serve as a tool. It is only when you use it properly the design outcome is usable and workable. You cannot fully rely on the software. It is because the software itself are designed to help you with your works. It is not actually replacing your work, especially when you come to the synthesizing of the knowledge, analyzing the problem. There will be a lot of engineering decisions involved. This you will have to do it yourself, and you will need to verify your design as well. The model result cannot simply be accepted without proper verifications. In case of any errors that result in errors in the design outcome, you must be able to notice it. These software are meant for the general applications. That means it is designed to be flexible for most of the general conditions, which when come to the special design and special considerations, there will be interventions by yourself. That means the software are not going to take the liability of an engineer, and you, the designer, are supposed to take the responsibility of any errors that have been done. Bear in mind that the software nowadays is rather friendly, which anyone can use the software. However, it is the responsibility of the engineers in terms of the design outcome. That means you may have the draftman help you to do the modeling, Or in the industry, you may have junior engineers to help you to model the structure, even though to produce the technical drawing. The senior engineers or the professional engineers will still need to check the design outcome. Whichever errors occurs that cause damage of the structures, instability of the structure, which at the end of the day might lead to implications of injuries, death, or costs, it is the responsibility of the engineers to take the liabilities. You need to aware about this. Now that we have introduced you the functions of the software as well as the role of an engineer, let us proceed with our discussions, provide some technical insights regarding modeling the reinforced concrete structure using some design software, which in this case we will focus more the discussions in terms of one of the common software used in the local industry, which is known as the Esteem. There may be other more software, but the principles is applied. This will serve as an example. If you are using another software, probably you can adopt the principle behind it, which in this case, the design software, for example Esteem, may be used for the analysis, design, and to produce the structural plan. This software is rather powerful and it has been widely used in the local industry. However, you need to aware that whichever design outcome produced by the software, you will need to vet all the aspects throughout the pipeline of the modeling. You know that a typical modeling process, there will be input and there will be modeling process and there will be output. Every single part of it needs to be properly checked. This including the input, where you need to vet all the design parameters such as the materials used, the design code, the bar size, as well as the properties of the materials. This needs to be in line with your ultimate design, when these parameters and the properties is either clearly written in the structural plan or commonly adopted in the local industries. For example, the bar size. There are common bar size, which you have to control the parameters at the input stage. You know that the process of the design, it will be analyzing the load. Where you're going to impose the load, you still need to check extensively the Eurocode in terms of the magnitude of the load. Basically, what we have discussed about the design and analysis part in our previous videos shall apply also, only that you have the software to help you with the calculations. And then once you have the loading confirmed, then you will need to produce the key plan in the software. This key plan is on basis of the architectural drawing. This is where you assign the size of the member, the size of the slab, the size of the column, and etc. The process, it will be basically similar as what we discussed about the structural key plan in the previous videos. You will pre-assign certain common size first for the software to help you to run the analysis. In the case that any members fail, the software should notify you. You will have to do a numerous try until all the members pass. There will be a lot of trial and errors. Whenever you make modifications in terms of the key plan, there will be analysis, the load will be distributed, and there will be design. The amount of reinforcement bar is proposed. If the member fail, the software will notify you and you know which member you should make modifications to improve it. The entire process requires an extensive knowledge in terms of the technical as well as the industrial experience. You need to know the practice in the local industry so that you can come up with a really friendly designs to the contractors. The software is powerful enough to model the structural key plans and the compilations of the structural key plan. It can give you a 3D view on the structures. This will be quite helpful for you to imagine how the structure looks like. And based on the slabs being assigned onto the member, it is easier for you to observe the structural integrity among the structural element. And you can actually zoom into the 3D view to see how the surface rise and drop with respect to the adjacent members. This is really good for you to imagine how the structural element will look like based on the key plan that you produce. Whether the slab is actually sitting onto the beam, is there any misconnections between the structural elements? It even gives you an idea whether the pile foundations will clash into each other if the columns are closely spaced, as well as based on the pile size that you proposed. When you do this modeling, you're going to expect yourself with a lot of trial and errors. Normally, I will recommend you to model the structures part by part, floor by floor. The reason being is, it is easier for you to detect if there is any problem with the structural integrity. Once you confirm part of the structures are okay, then you extend the regions that you model. This is for you to quickly pinpoint in the case that there are any mistakes or any problem with the structural integrity. Normally, you don't have to model the entire structures, which there are so many mistakes later that can be found. Then you have the difficulty to pinpoint which problem is associated with which. In terms of the productivity, modeling parts by parts, it will be better, as once you confirm one part, then you will extend it, and whichever mistake, it will not due to the part that you have confirmed correct. That means it will be due to the extended part. Then you focus your troubleshooting process based on the extended part for you to quickly pinpoint the problem. And you proceed this process until you finish every floor, proceed to the next floor, and until you finish the entire structure. I believe those have the chance to expose to the software will know what I'm talking about here. Next, you know that the modeling software are meant for the high degree of flexibility, which are intentionally designed to cover as many types of structures as possible for all sorts of design. However, most of this software can only help you to model the typical size or shapes of the structural element. The meaning here is, normally we use this software to model the main structural elements, which is the significant part of the structure. We are talking about the skeleton frame system. For those minor parts, as well as the complex design of the structural element or the architectural features, this you don't have to incorporate it in the main design unless you are advanced software user. But remember, if you don't put those into the design, you make sure the existence of the loops are being properly considered, and whichever not being modeled due to the complex design, this will need to be processed later at the levels when you do the structural plans, and make sure you have those incorporated in your structural plans and detailings. Next, you run the analysis. You need to carefully check every single design outcome and verify the result properly. Normally, the software will give you the result in terms of the moment and shear, which you can observe from their design reports. You will need to vet through the design report if there are any illogical response of the structure. Take some time to do some verifications. Maybe randomly choose a few members to check against your manual calculations or your design spreadsheet. This is the reason why I normally encourage the students, when they do the assignment for reinforced concrete structures, try to develop your own Excel spreadsheet, which it can be useful in the future, which you can use it to cross-check the software that you use in your working career later. You should also check the design on certain critical area, especially on the area that you do not have confidence in terms of the structural integrity, or the design seems to be rather special, which is other than the usual. Probably you need to pay more attention in terms of the design there. Also, when you check the design, you need to look into the parameters being used. Whether did you key in the right design parameters that you have overlooked during the input stage, as a means to cross-check that you have keyed in the input correctly. And you can also make relative comparison among different members by observing the looks acting onto the members in terms of the share and moment, in relative to the other members in terms of the amount of reinforcement bar or the size of the members, to see there is any logical correlations, as well as the looks acting onto the member should theoretically have some relation with the coverage in terms of the area, as normally we apply the load on basis of load per unit area. This at least will help you to have an idea whether your model result is correct. These are another example in terms of the analysis result, where the software help you to summarize everything in tables for easy reference. It is also for you to check in terms of the design output. Is it within the range of the setting that you intended to be, or did you miss any settings before you run the analysis that give you certain outcome which you are not desire of? What you see here, when you use this software, it is a tool to help you. It makes your works to be simpler and more productive. However, you cannot fully rely on the software. The software help you indeed, but you need to constantly cross-check and monitor if there are any errors or mistakes happen due to some overlook or not familiar with the usage of the software, not really fully aware of the features. There are quite a number of factors that can lead to you problem with the analysis and design, and error in terms of the outcome. Therefore, it will be a good practice for you that you monitor carefully at the input stage, and all the features and specifications you will have to go through it. Read through every single detail of it. If any inputs there or any parameter you are not familiar, try to make it familiar. Search for references and learn what are those, how it will apply to your structure, and how will it influence your design. And then in terms of the design output, not only for you to check the design, there are many ways for you to cross-check the inputs that you use in the design, because there are calculation steps outlined and demonstrated by the software, as well as you can make some logical comparison between structural elements. Then you will know more or less whether your model result is reliable and accurate. Spend some time to do some random checking from manual calculations or with your Excel spreadsheet to confirm the design. Based on what you understand, the design outcome should be similar to your manual calculations. If you are using the same set of data input, in accordance to the same code of practice, namely Eurocode or BS, the output should be more or less the same. And this is the way that you can do some verifications.